So I'm Robin this side. So today we will be solving this question from GATE 2023 Physics. Now before I give you the answer and tell you how to solve this problem, I would like to introduce this problem. So what are the concepts that are required to solve this? So as you can see on the right side, this is from the topic quantum mechanics and the subtopic 2 and 3 dimensional system, where you learn about the concepts of angular momentum and the spin. Now as you can see the statement of this problem, that it is related to the Stern-Gerlach experiment, which is a very famous experiment in the quantum mechanics and the old quantum physics theory. So which basically tells you what is the probability that a particular angular momentum, if you pass through an apparatus with the magnetic field in the z direction, and what possible things and with what probabilities, with what probability of what states it can split into. So yeah, that's the idea. So before getting into this, I would give you the brief introduction to this Stern-Gerlach apparatus. And before that, we read the problem. So you have an atom with a non-zero magnetic moment, and it has an angular momentum, basically the initial state, which corresponds to the angular momentum square root 12 h bar. So that gives you idea about what the initial state which you are putting on the apparatus and putting it through the apparatus. So our point to find is how many beams that beam of the atoms will split into. So it will split into certain probabilities, right? So let's see that. So what the apparatus is, if you look at it very carefully, it's a magnetic field in z direction. So Bz, and you are pointing a beam of particles. So the energy, if you write the Hamiltonian, that it is interacting with the field is the magnetic moment, which is non-zero in this case, times B. Now which is Z in this direction. Okay. So if you write it in terms of the angular momentum, if you remember, this is the Jz Bz, since your B is in the Z direction. So your Hamiltonian operator, if you say, is basically the Jz, the Z component of the angular momentum. Now what is your initial state? Psi, let's say I, which is J equal to 3. Now how do you see that? Because the angular momentum of the initial state of psi I is square root 12 h bar. Now you know, if j square psi is the eigenstate, psi I the eigenstate of j square operator, then it has to be j plus 1 h bar square psi I. So basically if you compare j plus 1 equal to 12, now that would be corresponding to j3. So 3 into 3 plus 1. Right. Now that doesn't mean your beam will be splitting into 3. So that's the common mistake people can make. So 3 is not the correct answer. Just be careful. You have to not choose this, right? So now why is it so? Because you can write the psi I as the probabilities of what states it splits into. So it's j equal to 3. Now corresponding to j, it can be your state can be the corresponding to m, so right. uh, so this would be psi jm. Now mj, if you look at, that is nothing but, it can goes from -3, -2, -1, 0, 1, 2 and 3. Okay, so that means you have the 7 states which you can write. Initial the beam which you put as a linear combination of the 7 states, right? So that means your beam is gonna split into 7 beams with probabilities. Okay, so that shows the correct option is 7. Right. Thank you.